Hey everyone, this is Parko Suthar, and today we will learn about what is function. Now let us discuss it by one example and then we will discuss the definition. And it is also says like this, it is a function or a mapping. Let A be a set of 30 students and let capital B be a set of 40 chairs in the classroom. Now the correspondence between A and B is student sitting on a chair. It's called function if and only if every student is sitting on a chair. Okay, every student is sitting on a chair and no student is sitting on two different chairs. No student sitting on two different chairs. Obviously, one student cannot sit on two different chairs. Note, and if any student is standing, then f cannot be a function. So this one is very important example, student sitting on a chair. So all you have to remember, every student is sitting on a chair and no student is sitting on two different chairs. And if the student is standing, then it cannot be a function. Now let us discuss the definition. Let A and B be two non-empty sets, then a function or a mapping f from the set A to the set B, that means the students to the set of chairs, is a rule which assigns to each element A belongs to A to a unique element B belongs to B. It is denoted by like this, f A arrow B, which reads as f it is a function from A to B. That means a function from students to chairs. Now if f equals to A to B, then f of A equals to B. Element B of B is called image of A of the set A. Now the left portion, that means this A, is known as domain and this B is known as codomain. That means set of all the students are domain and set of all the chairs are codomain. Now range of f. F equals to set of B such that B belongs to B and f of A equals to B or some A belongs to A. In short, uh, all the students which are sitting on a chair, so those chairs which are occupied, it is a range. In codomain there can be many chairs, but what is range? Range means whatever the chairs are occupied, it is a range. In other words, range of F is the set of all images of the elements of A under F. Now we can represent function by a diagram like this. Now let the interiors of the two closed area represent the sets X and Y. So this is X, this is Y, this is domain, this is codomain, and yes, that means here the students and here the chairs. So one student is sitting on chair D, second student is sitting on chair B, and third and fourth sitting on same chair. Remember, one student cannot sit on two different chairs, but all students means or maximum possibility, all students can sit in one chair. So that means this is possible. For example, if A equals to XYZ, that means domain is XYZ. B, ABCD, that means codomain is ABCD. Decide whether or not the following are functions from A to B or not. If they are functions, give the range each. If not, tell why. First, we'll list all the examples and then we will discuss. Now, first, f equals to xa, yb, zc. That means here xa, that means this left portion is from domain and this is from codomain. So xyz. Okay. Now in domain xyz, so just remember every student should got their chair and no student should sit on two different chairs. This is the only points you have to remember. And last one, and no student is standing. Okay. So xyz. So here x image is A, y's image is B, and z image is C. That means each and every student got the chair. Okay. And they are different. So this is a function. Now here, xa, yc, zb, and xc. So here image of x are two different. That means one student is sitting on two different chairs. So this is not possible. So this is not a function. Next, xt, yb. Now in now in domain we have x, y, z, but here in function there is no image of z. That means that student or that z or z standing. So again, it is not a function. Next, xa, yb, zt. Yes, x, y, z all have got their chairs and they are different. So this is a function. Now y. Oh, so one student is sitting on four different chairs. So that is not possible. And also x and y, they both have not image. That means they both have not got their chairs. So it is not a function. Now xb, yc, zd. X, Y, Z, B, C, D. Yes, it is a function. Now here in question, you also asked about range. So in first one, what will be the range? So whatever the chairs they've got, that means A, B, C. So range is A, B, C. In this one, range is A, B, D. And in this one, range is B, C, D. However, the codomain is A, B, C, D. But in range here, you have three elements. Now, what are the types of functions? First, identity function. Now let A be any set and f be any function defined on set A. Then the function f from A to A, and if f of x equals to x for every x belongs to A, then it is known as identity function or mapping, and it is denoted by I of A. Next, constant function. Its name suggests it is a constant. So f be any function defined from A to B, and it is defined as f of x equals to k, some constant. Then it is known as constant function. So here identity function, that means f of x equals to x. So one's image is 1, two's image is 2, three's image is 3. So this will be the graph. And for constant, all the domain, that means all students are sitting only in one chair. Okay, so 1, 2, 3 in codomain there are three elements 1, 2, 3, but each and every student is sitting only in one chair. That is possible. So it is a constant function. Now one-to-one function or injective function. A function f from A to B is said to be one-one mapping or one-to-one correspondence or injective function. If for every A1 A2 belongs to A, f of A1 equals to f of A2, that implies A1 equals to A2, or in another way, A1 not equals to A2, that implies f of A1 not equals to f of A2. What does it say? For every A1, A2 belongs to the domain. If their image is same, then that element is same. That means everyone has different image or unique image. Or here, if that elements are different, then their image is different. So that is one function. For example, here function f is from A to B, domain is 1, 2, 3, 4, and B x, y, z, t, q. Okay, one's image is x, two's image is y, three's image is z, four's image is t. So it is a function and one function as they have different images, unique. On to function, it is surjective. A function f from A to B is said to be onto mapping if each element of B is f image of at least one element of set A. In this case, the range of f is codomain of B. That means whatever the codomain, it will be the range. For example, f A to B 1, 2, 3, 4 and x, y, z. So what will be the graph? Okay, so here whatever the codomain, and that is also the range. So it is an onto function. So here the element of B is f image of at least one element of A. Now one onto function, or that means bijective function. A function f from A to B, which is 1 as well as onto, is called bijective or 1 onto function. For example, A to B 1, 2, 3 and XYZ. Then what will be the graph? See, this is 1, 1 as well as the range is the codomain, so it is onto, so it is the bijective function. Now what is inverse function? If f from A to B is an 1, 1 and onto, that means bijective mapping, then the mapping f inverse, as its name suggests, inverse. That means the function is f from A to B, then its inverse will be from B to A. So f inverse B to A, which associates to the element B belongs to B, to the unique element A belongs to A, such that f of A equals to B is called the inverse of the mapping f from A to B. Note, if f is bijective, then f inverse exists and f inverse is also bijective. That means if it is 1, 1 onto, then f inverse exists, otherwise it does not exist. And f inverse is also 1, 1 and onto. Now composite of function or composition of functions. Now let's consider three sets ABC, f and two functions f from A to B and g from B to C. Then GOF is the composition of f and g from A to C. How? That is GOF of A is from A. So GOF of A, that is G of f of A. Now f of A got some image, so that is B, and G of B, that is also some image, so C. So for every A belongs to A, and that is C of f of A. Now here, C, there are three sets A, B, C. So f is from A to B and G is from B to C. So what will be G of f? That will be from A to C. So that is G of f. For example, let f of x equals to x plus 2, g of x equals to x minus 2, h of x equals to 3x for every x belongs to R, so in the real numbers. Find g of f, f of f, h of g, f o, h of g. Okay, so three functions are there and we want to find these four compositions. So let us discuss first one, g of f. Now g of f of x, so that means it is g of f of x. Now first, what is f of x? F of x is x plus 2. Just put that value, so that will be g of x plus 2. Okay, now what is g of x? So here g of x is x minus 2, but here we want to find g of x plus 2. So here whenever x is there, so here x minus 2, that means whatever the x is there, that x minus 2, but here instead of x we have x plus 2. So what will be the next step? It will be that whole term minus 2, that means x plus 2 minus 2, or just replace x by x plus 2, so x plus 2 minus 2, so that is x. Easy. Now what is f of x? So f of x, now what is f of x? That is x plus 2, so just put f of x plus 2. Now again, what is f of x? That is x plus 2, so just replace x by x plus 2. So what we'll get? X plus 2 plus 2, that is x plus 4. Next, HOG of x. First, let's see what is h and g. H is 3x and g is x minus 2. Okay. Now what is g of x? That is x minus 2. Now what is h of x? That is 3x. H of x is 3x. So replace x by x minus 2. So 3 times x minus 2. So that is 3x minus 6. Next, FOH of x. So this is the composition of three functions. So this can be written like this: f of h of g of x. So that is f of h of, what is g of x? G of x is x minus 2. So now we will apply h. Now what is h? That is 3x. So f of 3x, but instead of x we have replaced x minus 2. So 3 of x minus 2. So that is f of 3x minus 6. Now what is f of x? F of x is x plus 2. So replace x by 3x minus 6. So 3x minus 6 plus 2, and that is 3x minus 4. Easy. Next, last one. The function is given, find f inverse, its inverse. So just set y equals to this. Y equals to f of x. Therefore, y equals to 4x plus 3 divided by 5x minus 2. Now interchange the role of x and y. So whenever we want to find inverse, just interchange x and y. So what we will get is y, that means x equals to 4y plus 3 upon 5y minus 2. That is just a cross multiplication. 5xy minus 2x equals to 4y plus 3. So 5xy minus 4y equals to 2x plus 3. Now here we want to just subject the y. So what will the y? That is f inverse x. So 2x plus 3 upon 5x minus 4. Okay. Thank you.